Alright guys, I'm going to help you out a little bit with today's lab. You want to make sure that you have your digital scale, it's zeroed out. You need to make sure you have your beaker ready to go. When you place the beaker, you want to make sure it's zeroed out. So we're not taking the mass of the beaker itself. That's just where we're going to hold our sugar concentrations. Okay, you're going to go ahead and use the pipette, 10 milliliters. The way you'll read it, you want to make sure that it reaches up to the 0 line right here. It's kind of working backwards from a graduated cylinder. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 10th milliliter mark is there. Okay, so you're going to use the pipette bowl, and you want to make sure that this is kind of inserted. You just kind of wiggle it in and make sure it's in there nice and tight. And then when you suck up the liquid, you're going to press this and then move this upward. Okay. Alright, so we're ready to go, and we're going to start with our 0%, and we're going to add 10 milliliters to our beaker. And notice that now the mass on the scale is going up, and that's about 9.7 grams. So I'm going to go ahead and just add that there to my data table. 0% sugar, my mass was about 9.7 grams. And now I'm going to go ahead and do the same thing with 10. Make sure that you rinse out the pipette between each of the sugar solutions. So I went ahead and I added some food coloring for each of the sugar concentrations. So hopefully what you'll see, we didn't see that for those groups that were done, hopefully you'll see kind of distinction between the densities of these different sugar concentrations. So we'll do the 5%, which I added some red dye. And again, you want 10 milliliters of that. Make sure the meniscus is on the 10 milliliter mark. And we'll go ahead and make sure that you zero out, this is very important, zero out the scale between each reading. We're going to add that 9.9 grams. And next one, make sure you rinse your pipette. Now we're going to go to 10 milliliters, I mean the 10%, excuse me, and add the 10 milliliters of that. Okay, make sure you zero out your scale. It's about 10.1 grams. Anyways, you're going to keep doing the same thing for each of these different sugar concentrations. And so then what you're going to do next is you're going to plot them. Okay, so you're going to create a graph, and you're going to you're going to keep going up to about 25, just to kind of a stable graph, or up to where your axis allows you. And then on this side, on your Y, density. Okay, and if you notice your data points, depending on where it's at before your start, And so I'm going to start at 9.0, 9.1, 2, 3, 4, 5, 6, 9.7, 9.8, 9.9, and then, okay, oh, it should be 9. Remember, you're taking the density, so you have to actually move the decimal, and that would be 1.005, and then go from there. Okay, so what you'll do is you're going to go ahead and put your graph your points here for the sugar concentrations, and then go from there. So for the sugar concentration, the first one, 9.7, the volume was 10 milliliters. So divide that. That's going to give you 0.97 grams per milliliters. And that's what you're going to go ahead and plot there. That's for your 0%. And then for the 9.9 mass, for the 5% sugar concentration solution, you're going to also take milliliters and you're going to divide that. It's going to be 0.99. So that's going to be there. And so you're going to keep going, and then you're going to go ahead and graph that and then make hopefully a straight line. And then you will be able to then reference the beverages that you have to test. You will be able to reference on this graph their density, so that way you can calculate their percent sugar. And we'll talk a little bit about that tomorrow. But that's kind of like the first part on how to set up and calculate the density and setting up your graph. All right, I'll see you tomorrow.